What's up guys, my name is Cornelius Robinson and this is Overshoot. Today I want to give you an introduction into circuit simulation in Flux. So let's get into it. SPICE, or a simulation program with an integrated circuit emphasis, is not new. It was first developed in the 70s at the University of California, Berkeley. It has improved since then, but still requires an intimate knowledge of how components work. Computers generally handle tasks sequentially, line by line, whereas physical circuits operate in parallel, simultaneously. This makes it very difficult for a CPU to simulate circuits, especially in a web browser. In contrast, Flux takes the circuit being simulated and places the variables in a matrix. That matrix can be efficiently calculated by your computer's GPU in parallel. The way Flux does this is by using a simulation engine with an abstraction layer on top of it. This allows simulation models to be built on top of that by someone without a PhD. That being said, Flux is currently in beta, so models are still being developed. Currently, there are 12 primitives that we can use to simulate a wide variety of circuits. Each one has a set of parameters that can be manipulated to dial in the specific part we wish to simulate. Let's take a look at a resistor to see how it's structured in Flux. It's pretty simple. We have a simulation model object composed of the type of model as well as the value. In this case, resistance. Additionally, we have to map the inputs and outputs of the model to the part in our schematic. But I'll get to that later. Also, it's not shown here, but you can specify the tolerance and power rating as well. You can find all of this information and more at docs.flux.ai. Okay, now I want to take a look at one more primitive to show you how we can make models more specific. In this case, a transistor. Again, we can specify the type of simulation model and whether it's a PNP or NPN style transistor. We can also tweak the part further by specifying the leakage current and amplification factor indicated here by beta. Like all models, there are ideal values that can be used, or you can find these numbers in a datasheet for a more realistic simulation. Okay, that's about all I want to cover in this video. In the next one, I'll go into more depth and show you how to write some actual code. So make sure to like and subscribe, and I'll see you in the next one.